Hello and welcome back to another video series. In this video, we are going to look at what is a transistor, the symbol of a transistor, and the types of transistor that we have, and the operation of a transistor. So firstly, let's define what is a transistor. So a transistor is mostly defined conductor device that is used to amplify or switch electronic signal and electrical power. So it is the fundamental building blocks of most of the electronic circuit. Transistors are made from semiconductor materials like silicon and germanium and are widely used in a variety of applications, from a small microprocessor to a huge power regulation circuit. Since transistor is made up of silicon and germanium, they have the same working principle as the diode. Remember in the previous video of diode, I mentioned that if you can really understand what is a diode, it is very common that you will also have to know what is a transistor and the behavior. So let us look at the type of transistor that we have and the symbol and the physical component. So firstly, when we look at the types of transistor, so we have two main types of transistor. One is known as the bipolar junction transistor, or most people call BJT transistor, and the second one is the field effect transistor. And in the bipolar junction transistor, we have also two types of bipolar junction transistor. One is known as the NPN transistor, and the other one is known as the PNP transistor. And the example of a field effect transistor, which can be known as the MOSFET. So with the BJT transistor, the NPN transistor are mostly used. Some of the mostly used in electronic circuit. So we will look at why the transistor is important in terms of the working principle. But firstly, let's look at the two transistors. So you have the symbol given here. You have symbol 1 and symbol 2. So in this symbol, can you identify what is the two type of transistor that we mentioned previously, which is the NPN and PNP transistor? So the first one is known as the NPN, and the second one is known as the PNP transistor. The major difference you can identify from this circuit is with the arrow. They all have three terminals in common. The C represents the collector, the B represents the base, and the E represents the emitter. To understand how this circuit or the device operate, I will give you a scenario. You have a path which is coming this way, and you have another path coming this way. So in terms of the current we described previously, we have point A and point B. So in between, we can say there is a river flowing and there is a cliff. So if you are in point A, you cannot cross over to point B. So what you need is a bridge. So the bridge is known as the base. So without the operation of the base, that means we cannot allow current to pass from point A to point B. So when we talk about current, if you look at a transistor is operate based on the current, while the MOSFET on the other hand, which we will discuss later on, is controlled using the voltage. So the control mechanism acts as a bridge from path A to path B. So without this control mechanism, you cannot be able to move current or voltage from one place to another. So we can summarize by saying a transistor is a current control device and the MOSFET is the voltage control device. This is very important for you to understand. Now we are going to look at the symbol of a transistor with respect to what we call as the construction. In our previous video, we look at the construction of a diode, and the diode is made up of p-n junction, which is the n-type and the p-type. And we know that n-type semiconductor material and p-type semiconductor material are formed during the process of a doping. So similarly, if you look at the transistor, it is made up of n-type semiconductor material, p-type, and n-type semiconductor material. What you will identify from this construction diagram is the PN. This PN is similar to the diode. And in between, you have the what? You have the depletion region. With this diagram in mind, we can generate a diode equivalent circuit. So the symbol of a diode that we looked at previously, it is something like this, where you have the p-type and the n-type, and the current is allowed to flow in one direction. The flow of current, we mentioned that it is equivalent to the interaction between the holes and the electrons. So without this movement of holes and electrons, we cannot be able to generate the flow of current. By looking at this p-n junction diode, we have the p and the n, and the direction of current is flowing in one direction. So if we want to generate the transistor with respect to the diode equivalent circuit, we can add another diode but in the opposite direction. So now we have the n, p, and n. So this is now the diode equivalent circuit of the NPN transistor. How can we enable the base in this diode equivalent circuit? So the base is connected in the middle, which is the P region of the semiconductor diode. So firstly, if we apply some good amount of voltage, for silicon is greater or equal to 0.7 volts. For a germanium transistor, if we apply 0.3 volts to the base, that means in this P region, what will happen? It will allow the current to flow in this direction. Since it is known as the current control device, that means when the base is connected to a power supply and it is connected to the base, that means more holes will be accumulated at the p-type. And in that case, it will attract all the electrons in the depletion region. And similar, if this region is connected to the negative terminal or the ground, that means more electrons will accumulate here, which will attract more holes in the depletion region. Now it allows the current to flow from P to N. So in that case, there will be a diffusion in the current. That means more and more of the holes that is present in this region will now enable the current diffusion through the n-type on the other end to pass through. So in that case, if this is connected to another power supply, then it will allow current to flow in this region. The base, since it is only 0.7 or 0.3 connected to this P region, there won't be much enough current flowing through the circuit. If we connect, for example, another voltage source in this region, that means more of this current will now pass through the process of diffusion and from the P to the N. So we have now have the flow of current in this region. So we can simply define mathematically that IE, that means the current flowing through the emitter, that is the P to the N, will be equals to the current which is from the base plus the current of the collector. That means current flowing through this direction and current flowing through this direction. And mostly the current through the base will be small, while the current flowing from the collector will be large. In application where we will look at why the transistor is used mostly as an amplifier, that means the majority of the current will be from the current collector and not from the current base. In this video, we will only focus on using a transistor as a switch. In the later video, we'll look at how a transistor can be used as an amplifier. Since we already understand about what is the NPN transistor, now let us look at the PNP transistor. So how can you draw the construction diagram of a transistor? It is simply having three regions which correspond to the polarity, and from this symbol you can see that we have the emitter, we have the base, we have the collector. So the direction which is given from the emitter to the base to the collector, which indicate the direction of the flow of the current. You can now simply say we have from the emitter, it is connected to the p-type material, the base is now connected to the n-type, and the collector is connected to another p-type region. In that case, you have the PNP transistor. So the equivalent circuit, it is now simple. You can do or write the equivalent circuit. That means you have the N and the P region. So you can draw something like this and then something like this. So the P is always positive, N is always the negative, and another positive. Remember, P is known as the anode and the N is known as the cathode. So now you have the diode equivalent circuit of a PNP transistor. Since in this video we are focused mostly on the NPN. NPN is mostly used in all electronics. There you have it, the construction diagram and the diode equivalent circuit of the PNP transistor. So now we will look at the physical component of a transistor. A transistor comes in different sizes and different form, starting from through-hole component and the SMD, small mounting. So through-hole can be a large transistor that can be physically seen, the pins with the eyes, but the SMD is mostly small. If you can find the SMD in a mobile phone which are very small, you cannot be able to see once it fall down. And the through-hole, it's you can physically see in the circuit. So depend on the requirement of the circuit, they have come up with a through-hole component and the SMD component. Some of the things you need to understand with a transistor. So a transistor mostly operate as a switch or an amplifier. In order to have a transistor to operate as an amplifier,